Question number 10. The diagram shows a particle P traveling with speed v is about to collide a stationary particle Q of the same mass. So both the objects have the same mass, that is m. The collision is perfectly elastic. As it is a perfectly elastic collision, so the kinetic energy before collision is equal to kinetic energy after collision, and relative speed of approach is equal to relative speed of separation. That means if the two objects collide and both the objects are moving in opposite direction, so if the objects are moving in opposite direction, then we have to add the relative speed. Or if the objects are moving in this direction, suppose both are traveling in opposite direction, so we have to add the relative speed. And if the objects are moving in the same direction, so we have to subtract the relative speed. So this is the relative speed of approach and the relative speed of separation that we need to do. That if they are moving in opposite direction, then we need to add, and if they are moving in the same direction, then we need to subtract. Then and momentum is always conserved, that is momentum is always conserved. So momentum before collision is equal to momentum after collision, that is momentum is equal to mass into velocity. So which statement describes the motion of P and Q immediately after collision? So P and Q both travel in the same direction with the speed 1 by v. So by using relative speed of approach is equal to relative speed of separation, initially the relative speed of approach is v plus 0, that is v. Since Q is stationary, so v plus 0 is v. And the relative speed of separation, since they are moving in same direction, so we have to subtract. Since they are moving in same direction, so we need to just subtract this. So same direction with this speed, so the relative speed of separation is 0. That's why the relative speed of approach is not equal to relative speed of separation. So this statement is wrong. Then P comes to rest and Q gains a speed v. So P comes to rest and Q gains a speed v. So momentum of P is mass into velocity, that is mv, and the momentum of Q is 0 since it is rest. And the momentum after collision, that is P comes to rest, so momentum of P is 0, and after collision the momentum of Q is mass into velocity, it is mv. So as we can see that mv is equal to mv, so yes, this statement is correct. Then part C, P rebounds with the speed 1 by 2v and Q acquires a speed of 1 by 2v. So P rebounds with the speed 1 by 2v and Q moves with the speed of 1 by 2v. So as they are moving in opposite direction, so we need to add the relative speed. So v by 2 plus v by 2, so we get a speed of v. So this is same to the initial speed, so this could be the answer. But if we just calculate the kinetic energy, so kinetic energy of P half mv square plus kinetic energy of Q half mv square, where v is equal to v by 2, since v by 2, so we get the kinetic energy as 1 by 4 mv square, that is the final kinetic energy. And initial kinetic energy is half mv square, where v is the speed of P and Q is at rest, so 0. So in total 1 half mv square, and here we get 1 by 4 mv square. So kinetic energy is not the same, therefore this option is wrong. Then P rebounds with the speed v, so P rebounds with the speed v and Q becomes stationary. So particle Q becomes stationary, that is velocity becomes 0. So by using momentum, so momentum before collision is mass into velocity, that is mass into velocity, and Q is at rest, so momentum before collision is mass into velocity, and momentum after collision, and we consider the velocity towards the right as positive, and after collision P rebounds, so P rebounds and Q remains stationary. So as P rebounds, so its velocity becomes negative, so mass into negative velocity. As we can see that momentum after collision is not same as the momentum before collision, since there is a plus sign while there is a minus sign at the final answer, so this option is also wrong. So the correct statement is B.